Hi students, coming to the next topic, that is the merge sort. This is one of the example for the divide and conquer method. In the previous video I explained about one of the divide and conquer example, that is a binary search. Now let us see what is a merge sort. So before going to know about the merge sort, you have to know the basic plan what merge sort will do. The basic plan for merge sort is, first it divide the array into two halves. So whatever the array size that is there, suppose n size is there, that it's divided into two halves, n by 2. And next it recursively sort each half. Recursively sort each half. And next, after sorting the each half recursively, you will get the sorted array. And finally you have to merge two halves. So this is the idea of the merge sort. Actually in the binary search, the array itself you are taking as a sorted array. Okay, sorted array you are taking and you are searching the element by using the divide and conquer method. Whereas in merge sort, you are taking an unsorted array. So in that unsorted array, you are going to make it as a sorting array. Okay. Now let us see the pseudocode for this merge sort. Let me write first pseudocode. Merge pseudocode. So algorithm merge. So the algorithm is merge A P Q R. Okay. So first step. The first is, first you have to compute N1 and N2. What are the N1 and N2? N1 and N2 are nothing but the two halves. Suppose the array is consisting of some elements 2, 4, 5, 7, 1, 2, 3, 6. So this is a unsorted array. Okay, and here this is, let's take P, and the middle one you can take Q, and this is the R. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So this N1 and this half is N2. So the starting is a P and the middle is Q and the end is R. And first compute N1 and N2. Next what you will do? The second step is, copy the first N1 elements into, you have to copy this first N1 element into left hand side. L is left. 1 to up to N1 plus 1. And the next N2. So this is this. Next N2 elements into right hand side. That is R1 to N2 plus 1. So you are just copying the elements N1 into left hand side and N2 into right hand side. Now the third step. So what is the third step? You have to, L1 is N1 plus 1 up to infinity. And R is N2 plus 1 up to infinity. Means you have to recursively sort until you find out the sorted array. Fourth step, I1 J1. Let's start with, means the loop condition. The fifth one for K points to P, the starting to R. If the K is searching from P to R, okay, then do if L of I is less than or equal to R of J. Seventh, then A of K, means the element A of K is L of I. So what it represents? Suppose this is a L consisting of 2, 4, 5, 7 and up to infinity. So this is a P and this is a Q. And coming to the R consisting of 1, 2, 3, 6 and infinity. And this is a Q plus 1 and this is R. So first for K tends to P to R, we have to loop the condition until this is a recursively sorting. L of I, that is L of 1 is less than or equal to R of j, then A of k is tends to L of I. 8th step. Whenever L of A of k, L of I is stored in A of k, then I should be I plus 1 incremented. Else A of k consisting of R of j, then j should be incremented. Means we are just recursively sorting the each half, the left half and the right half, both we are sorting. Okay, so this is the algorithm of the merge sort. Now let us see the running time of the algorithm. Afterwards I will explain with example. Merge sort running time. So what are the steps for this running time algorithm? The first, you have to be divide. So for divide, how much time it is taken, means the running time of an algorithm to divide an array. So compute Q as the average of P and R. So you have to compute the Q. So Q is the middle item. So here did you observe that this Q is the middle one, means we are just dividing. So to divide how much running time it takes to divide an array. Compute Q as average of P and R. So that is the divide of n is the size of an array is theta of 1. So that is the theta of 1. So next is conquer. So for conquer means it's recursively solving the problem. Conquer is solving the problem and getting the solution. Recursively solve two sub-problems, each of size n by 2. So first half is n by 2 and the second half is n by 2. So you have to recursively solve up to 2t of n by 2. So the first half is 2 to n by n by 2 and the second half is 2t by n by 2, like that. Means you have to recursively solve. So and the next thing is third one. So that is you have to combine. After getting the sorted array of sub problems, you have to combine. Merge on an elements sub array takes theta of n time. So it takes sub array of theta of n times. So now C of n is equal to theta of n, and whereas that this is the time complexity, that is the running time, here is T of n is equal to theta of 1 if n is equal to 1. Suppose if n is equal to 1, the time it takes to run an algorithm is theta of 1. If it is not sorted, it takes t2 of n by 2 plus theta of n if n is greater than 1. Means if the array consisting of only one element, only it takes theta of 1. So if the n is the size of an array is greater than 1, it has to take the time as 2t of n by 2 plus theta of n. So this is how the running time of a merge sort will be for divide and conquer and for the merge. So in the next video I'll explain with an example how we sort an array by using the merge sort technique. Thank you.